Hi everyone, welcome back to Frosty Friday. So today we're going to do week number 6, which is a difficulty of heart. So which comes around geospatial data. So let's just see what this question entails. Week 6. So this week we're going to play with spatial functions. Frosty Lobbying is thinking of supporting some candidates in the next UK general election. What they need is to understand the geographic spread of candidates by nation region of the UK. Your job is to build both the nation's regions and parliamentary seats into polygons, and then work out how many Westminster seats intersect with region polygons. Be wary that some seats may sit within two different regions, some may not sit within any Northern Ireland, it's not including the data provided, and some may just be awkward. Okay, within the data, the part column is an integer given each landmass that makes up that region, nation, and etc. For example, the Isle of Man could be part 34 Scotland and part 12 of the Imperial Constituency. So, so in this question, we have given two, I think they're both two CSV files. So what I'm gonna do is create a staging, right, and then load those two CSV files onto the stage. So what I'm going to show you today is pretty much how to deal with geospatial data. So for anyone who don't know what geospatial data are, they're pretty much like geographical information that refers to any data that is associated with specific location on the surface, right? So for example, data that includes information such as geographical coordinates, as well as understanding the methods of analyzing maps or charts, for example, points, you have lines, and of course, polygons, right? So in here, we have given two data sets. So what I'm going to do is to analyze both data sets, right? So that I can create a geographical object, right? So let's just go back to FrostyFriday. So what I've done, I've created a staging and inserted those two files in, right? So what I did is let me list down the file. Just call it stage. Yeah, something like that. So as you can see here, I have uploaded two CSV files in there, right? So in Snowflake, talking about data types, right? When it comes to coordinates, we have a data type called geography, which entails points, right? So from A to B. Think of it as coordinates, right? Coordinates are not, I mean, they're numbers, right? But if you have actual coordinates in them, right, that defines a different story compared to numbers, it is defined as a geography data type, right? Because you will get decimal numbers for coordinates, and you will probably have lines or polygons. So when I say polygon, they represent shapes formed by straight lines connecting with consecutive points, right? We call them vertices, for example. These straight lines are known as edges or sides of the polygon. So I mean, reason this is difficulty of heart is because sometimes dealing with geospatial data can be somewhat intimidating, right? But I think I try my best of my ability to solve the challenge using Snowflake. So make sure that while doing this challenge, it is always handy to open up a few Snowflake official documentation side by side, making sure you understand how to deal with geospatial data. So, and then looking into the question here, and let's just go back to the question. We understand in order to create those polygons, you need first coordinates, which are points, and then you need lines, right? Let's say, for example, you have coordinate number A and coordinate number B. So you draw a line, right? You draw a line from A to B, and then B to C, C to etc. to make up the polygon, right? So again, a polygon is just a shape, right? So it can be any shape that you can visualize on the map, right? So, and you can see here, they've bold the word intersect, right? So when we say about anything related to intersection, we strictly talk about intersecting polygons, determine where two or more polygons overlap or share common areas, right? So let's just crack on with the challenge. So going back to Snowflake, so I've got two files in here. So I'm going to do is I'm going to create a file format, right? I'm just going to do create or replace file format. See, let's go to CSV format, right? So the existing there. type CSV, skip header, this one, yeah, for example. Okay, let me just create this, yeah. All right, done. Now, the next step I would do is I really want to, check how many columns those two files exist, right? If I just want to run this one, let's just play around with, I mean, even though, yeah, you have to create those two files anyway, right? You have to create a table coming from those two files, right? So I'm gonna do is check the columns, table, for schema, let's go to location. Location is gonna be the staging location here. It's gonna do something like this. Files, right? So just deal with the first one. Nations and regions.csv.gz. Yeah, it's .gz because Snowflake automatically compresses the file, right? Compresses CSV file. If you don't want the GZ at the end, in the put command, after saying put file and you give your file name, add staging name. After add staging name, you say auto underscore compress equals false. So now you will have just the CSV file without the GZ at the end, right? So I'm just going to keep as GZ because Snowflake automatically compresses the file, right? So that doesn't really matter which file you're working on. Now next I'm going to do file format. I'm just going to call this CSV format and ignore case true. Yeah, something like this. Checking for any errors. Okay, so let's see what we can see on this table here. So as mentioned before, first thing I would do is to look at the data. So more like how many columns would one of the files contain using the info schema command, right? So for this file, which I've chosen nations and regions, it has 6 columns, right? You can see here 6 columns. Don't say 5 columns here because this order ID is 0-based index. So just look at this number here, right? So you know there's 6 columns. So the first 2 columns being text or varchar, and the rest to be number columns, right? So bear in mind, for my initial assumption, looking at this data type here, especially for column number 4 and 5, right? These two, they are decimals, right? They have a precision number as 6, right? You can see here, those two. So this can be denoted as a type of float. So this is an indication this has something to do with coordinates, right? So there are numbers, decimal numbers, but they are probably like X and Y or something, right? So we can check the same for the other files too, right? So what I'm going to do is just going back to, I mean, you could just do something like this, right? So nations regions contains 6 columns. This contains how many? Let's see. Let me just delete this page here. So this contains how many? Oh, this contains 7 columns actually. So this second CSV file, Westminster, contains more columns than the nation's regions columns, right? So one contains 6, this contains 7. So by looking at this, my assumption, let's see. You have given 3, float numbers, right? These are float, and this is the whole number. So let's just see this data more further, right? This is just me assuming, okay, there are coordinates involved, etc., right? So what I'm going to do here is I want to check the columns. I'm going to see the data itself, right? Columns plus the data. So I'm going to do is select. So I'm going to do select metadata, file name, metadata, let's see, file row number, yeah. So because we're creating a table on top of those 2 CSV files, let's just go back to this. And let's just start off creating a table on this particular CSV file, right? So I'm gonna do is copy paste in here. Just gonna run this. So I can see that this contains 6 columns. So I'm gonna do something like this: 2, 3, 4, 6. Right? Okay, this contains 6 columns. So from this location here, it's called week 6 stage. You may have a different naming for that. So 6 stage, right? And then I'm gonna say, oh no, just I think that's all, right? So let's just see what this entails. Okay. Only what's on the display, please. Rows. Okay. I mean, this contains 87 87k rows, yeah, if you round it up. So if you see here, we have, okay, if you just go like this, okay. As I mentioned before, the metadata file row number, if it's 1, it's always going to be the column names. If you have the column names, nation or region name, type, sequence number, longitude, latitude, and part, right? So yes, I can see these are region names, these are type of region with the regional nation, sequence numbers, longitude, latitude, and part, right? Okay, I'm just looking into this, so I get to understand the data a bit more, right? So I can tell that column 4 and 5, which is longitude and latitude, are pretty much your coordinates, right? In geospatial terminology, longitude means that um, lines that run vertically from the North Pole to the South Pole, right? Latitude means that lines run horizontally around the Earth parallel to the equator. So pretty much like this is going to be your x-axis, right? And this is going to be your y-axis, right? So x comma y in the coordinates, right? So we use these two columns to work around the data, right? So what I'm going to do is just going to work around the data and see. I mean, before doing all that, we have to create a table, right? So I'm gonna do is I'm gonna create a table, right, for this, and then I'm going to create some coordinates, right? So what I'm gonna do first things first is just create a table. So the reason why I'm gonna do is create or replace table. Let's just see, call this nations, regions, something like that. So the way I do this is, if you see my previous challenges, you see the way I create tables. Okay, you create the table first and you use the copy into statement, right? To load the file into a table. I'm gonna do everything in one go, right? So without having two separate SQL statements, I'm going to do everything in one. So the way you do it is, okay, I write this table command, so ctask command, and then I'm going to pick the column. So you used to do $1, which is nation or region name, right? So I'm gonna give this a data type, right? So I'm gonna call this let's call this nation or region name, right? 2, go voucher as what's number 2 type, right? 3 as sequence number. 4. So I mean sequence number, do this as number, right? So if you don't know what data type it is, just run this command here, info schema, right? So you can see these are the data type you want to match, right? Text or varchar, of course, the same. Number, these two are use float, and the last column is number. So I'm gonna do here, just gonna run this command here. So in order to see the columns is do something like this, right? Metadata file name equals 1. No, sorry, metadata file row number equals 1. Sorry, row number, right? Something like this. So these are your columns, right? So you can see clearly these are your columns for this nation region CSV file, right? Which contains 6 columns, and the other contains 5 columns, right? Which is Westminster 200 points CSV file, right? So here you can see clearly this has longitude and latitude. This also has longitude and latitude. So I know for a fact that, okay, we need to create coordinates for those two CSV files, right? So I'm going to do here is, okay, let's just begin creating a table on nations regions, right? And number 4 is going to be your longitude. So I'm going to add that as a float. So something like this as longitude. Don't forget your commas here. Something like that. 5. I'm going to do float as latitude. 6 is going to be a number as part, right? Something like this. So here you don't just say from, because this is your table from the location given. So which is called, if you run this first command, this is your location, copy that and paste here, right? And don't forget the @ sign at the front. So from this CSV file here, and give a file format. So you say, it's going to do that in the next line, right? So file format. So open up something like this. File format, right? File underscore format. Sorry, file format. I'm going to call this as CSV format. Just copy and paste underneath here, right? Something like this. So I'm going to do is run this table. Okay, this table has been created, right? So I'm just going to do select star from nations regions. So I'm just going to copy and paste that here and run the command, right? So I can see that I've created a table, right? So I can see we have around 5,000 records, right? The table has been created, right? So I can see the coordinates here. I can see the sequence numbers. I can see the region, the nation or region name, and the part. So what I did here is simple create or replace statement with the following columns, right? From the staging location. So what we normally do is we create a table, we add those columns, right? And then that's where you create a table. Yeah, just a standard table. But if you want to load the CSV file into the table, you use the copy into statement. But I don't need to do that. I've done this everything in one single go. So this is a good way of loading the file quickly, right? Now I've created a table, right? So what's next? So let's see if I can create the other table, the Westminster table, right? So let's just see here. What do we get? So again, what I'm gonna do is just copy, paste in here. See what we can see. So delete this part. Something like this. So okay, I'm gonna do again. This has 3 varchar, and then you have 3 floats, and then a number, right? We can go back to this. Let me see in here. Okay. We can clearly see the we have 5 columns, right? I'll just do the same. So I'm gonna do I'm just not going to copy paste like this, but I'm gonna do is create from scratch, right? So create I'll replace table, something like this, yeah. Just gonna call this Westminster. Say Westminster. See points, right? So select statement. So again, the first one is going to be a varchar, right? So there were 3 varchars, right? So I'm just gonna do something like this, and then I'm gonna do something like this, right? So the first column being the first one here, as you can see on the table. Okay. Okay, sequence number. Let me quickly see something. Sequence number is given as text. Okay, a bit strange, but I'm gonna change this to we'll change it to a number. Right? Okay. I think the way the CSV file has been generated is given this. Let's go back to this one here. Oh no, not I mean this statement. Just see the columns. Okay, part. Right. Oh no, sorry. This is gonna be called sequence number, right? Sequence num. Third column is longitude. Hold up. Why is longitude? Let me see here. Oh, sorry, I was looking at the wrong one. Sorry, this first one here, right? So, yes, run display here. Okay, all the text numbers. Okay, okay, that doesn't matter. So what I'm gonna do is here. Looking into this. Okay, I'm just gonna look into longitude, latitude. I'm gonna do this as float. It's gonna put common like this. It's gonna do this float, latitude, and then 5, which is the last column, right? There's no 6th column, right? This table does not have a column called type, right? So I'm just gonna call it part. No, sorry, number as part, right? Something like this, right? And then what I'm gonna do is get the name. So I'm just gonna copy this, add sign, paste like this, right? File format, CSV format, right? Something like this. Okay, let's see. Numeric value carry comlock is not recognized. Okay. Watcher number, floor number. Okay. So if you see here, I think one quick thing to notice is that if you're importing the CSV file, right, because you're using the same file format, probably for the same two tables, if I've got an arrow like this, right, what I'm going to do is I'm going to copy this description here, right? I'm going to copy that. And if you could open up your Excel sheet, right, for the same table that we're going to create, which is the Westminster table, right? I'm just going to do replace F, paste into here, right? So I'm going to do is find next. Okay. You can clearly see why this file format is not working for this particular file. The reason why is if you see here, CSV is a comma separated file, right? So we have AYR, comma, Carrick and Comnock, right? This basically tells me that, okay, the first column is AYR and the second column is Carrick and Comnock. But if you see here on Snowflake, the second column is a number. It's not a varchar. So therefore you got this error, right? So for example, on our previous file, which is a nations to regions, we don't get any commas within the Excel cell, right? So that's why we're trying to see, okay, where the error happens, right? In this case, it's because in this cell, it may be occur in, just few lines below or whatever, right? So just make sure that if you receive an error such as something like this, right? That's an indication that you need to go back to your file format statement and tweak a little, right? The only way we need to do is if you're importing any CSV files that has fields that are separated by commas and some fields that contains commas with them, right? You might use the easier method, or I mean, not the easier method, but it's one of the best method that you can use in order to achieve best practice is to include field optional, right? So optionally, field optionally enclosed by, right? So what does this mean is that command is to specify that fields may optionally be closed within double quotes, single quotes, any characters, right? So I'm going to here do double quotes, right? So I'm going to do something like this. Yeah. So it makes sure that this field or cell is wrapped around with double quotes as a single field, even it has commas, right? So if you see here, this bit here, So if you don't specify field optionally enclosed by command, this comma separated file CSV is treating AYR as the first column and Carrick and Comlock as the second column because it's separated by comma. But if you added field optionally enclosed by command, it will specify this whole cell as your first column, right? So because this statement or this text file, text cell will be wrapped around with double literals pretty much, right? So that's what this doing. So let me just run this file format and then run this again. Let's see if you get any errors. Okay, it's been successfully created. So this is how it works, right? Just let me just do something from this table. Let's see what we get. Okay, this is pretty much looking nice. Right, you see here, let me just scroll down here. Look, you see? Now we haven't received any errors. And this is treated as a single cell and the first column, right? Okay, we have done this part here. So let me just look into those two tables, right? So we have validated and analyzed a bit of the data, right? So I'm just gonna check those two. Okay, it's all good. This has 5k rows. This is around 81, right? Okay. What we're going to do is, okay, let me just go back to the question. Let me just go this way up. Let me just go back to the question. Your job is to build both the nations, regions, and parliamentary seats into polygons, right? And at the end, it's telling us to create this particular table, intersecting, different regions or nations, just to make sure that they include in that particular, shape of area, right? So, or determine where two or more polygons overlap or share common areas. More detail, right? That's why we strictly talk about intersecting. So what I'm going to do is because we're dealing with x-axis, I mean just say x point and y point, which is longitude and latitude, we want to create a polygon, right? This is where the challenge comes in, right? You need to know how do we create polygons, right? First, you create a point, which is the coordinate. Let's say you create a point and then you point basically, which are your coordinates, and then you create a line. And after that, you create your polygons, right? You can't create a polygon from scratch. You need to first create a point, and then after the point, you create your line, right? So you're from A to B, and then a polygon around it, right? You can get that shape, right? So the first thing I would do is, there are n number of ways you can do it, right? So there are many methods you can do in order to achieve the same result, right? The first thing I would do is create, let's say, coordinates for all of the, tables. So for now, what I'm going to do is start with one of them. So I'm going to start with nations and region table, right? So here, what I'm going to do is, the first thing I would do is create coordinates, right? So the way I would do it is, I'm just going to select all the columns, right? So let me open up this table here. Let me see what they have. Okay, select nation or region name, right? Type, sequence number, so longitude, latitude, and part, right? Something like this from nations, regions table, right? This is similar to the select statement above, right? So in order to create the first coordinate, so I'm going to do is, there is a method the reason why we know you have to create a coordinate between longitude and latitude is going back to the Snowflake documentation. So the geography data type, it specifies here, if you have geospatial data, for example, longitude and latitude data, you should convert and this data in geography columns rather than keeping the data in the original format in bar chart, variant, or number columns, right? Storing your data in geography columns can significantly improve the performance of queries that use geospatial functionality, right? So going back to this, the first thing I would do is create a coordinate. So in order to create a coordinate, is you need to make a point, right? So how do we create pointers in here? Is if you go to this bit here, so in Snowflake documentation, there is a function called st underscore make point or st point, right? Both doing the same thing. So if you see here, so what does it do is it constructs a geography object that represents a point with the specified longitude and latitude, right? So we scroll down below. Okay, the function returns a value of type geography, and you can clearly see here, right? So imagine this is your longitude and this one your latitude, right? And you can see you get a coordinate out of this. So we're going to do the same. So the first function we're going to call is you have to create a point in order to create the polygon. So just use this function, right, to begin with. So going back to Snowflake, so I'm going to do here after is make point, right, longitude and latitude, right, something like this. Let me see if I got this correct. Yeah, that's correct. So something like this. So I'm going to run this table here. You can see I have those coordinates, right? Okay, one more thing to notice is you can change the way the table represents your coordinates, right? Look, you have this as probably like an array structure or like a JSON object, right? We can change this something similar to what we've seen and something in this Snowflake documentation, right? Here we have something called point, and then we have this coordinates. So in order to do that is going back to Snowflake documentation, if you scroll down, you get to see different, let's say, parameter value, right? So if you scroll down here, this is one parameter value. So if you have those points, right, on line string, etc., as you can see an example, if you alter the session by GeoJSON, you get a JSON object, right? So you would say, okay, so type point, which is coordinates, right? This is the point, first point, etc., right? If you set this to WKT, which stands for well-known text, this will receive the text, right? And you will get a different output like this. So WKB stands for well-known binary. So you get a binary object, right? It's a geography object, but as binary, right? So this stands for extended well-known text. So you get more information out of this, right? So again, this stands for extended well-known binary. So again, this is a bit difficult to read. So the easiest method to read is something like this, right? So I'm gonna change this session to WKT, right? What I'm gonna do is I can just copy this, going back to Snowflake, right? So because we have this, because this is pretty much difficult to read, right? So I'm gonna change this to alter session set geography output format WKT, right? First run this and run the table. You can see I have changed the format of my coordinates. So this is much more easier to read, right? This is a point and this is your x-axis, your x and your y, right? Now, what's the next step is, okay, we have created points, right? We created a point for all the regions, right? What I'm going to do is create a table on top of that, right? And then work across with this table, right? So I'm going to do is create this table. So I'm just going to points in order, right? So I'm going to do points in order. You can just call it anything, right? I'm going to do something like this. Just going to do this keyword. Just going to see something like that. Okay. Let's make it more neat. And here I'm just going to say order by, I'm going to order this by nation. Just going to order this by nation. It should be a nation region name. Name, type, sequence number, right? I don't think I need these two columns. Don't think I need this, but okay, I don't need these two columns here. It's parts, right? Okay, something like this. Okay, something like this. Order by. Okay. Cool. Okay, I'm going to create this as. Let's call this as. So geo points, right? Geo points. Okay, table's been created. Then let's just see the table. Points in order. Okay, you see here, because we ordered this by the whole rest of the columns, we see this geo first one, this is the second one, right? You can see the sequence numbers, right? Etc. Right? So okay, this is an order. So what we're going to do is, so how does it work, right? So we have this table. So how do we actually create a polygon? So we need to create a starting point, right? Or something called your origin. Now, when I say origin, not the coordinate 0, 0, but your starting point as in what's the initial position, right? On the map in order to create, for example, this region, East Midlands, right? So if you see here, anything with the sequence number 0, that's your first point, right? Because this is ordered by the sequence number, right? So what we're going to do is we're going to create a starting point for any coordinates that have a sequence number of 0, right? Because sequence number 0 means it is your starting point. This is your sequence number. How do you draw my line from sequence number 0 to 1, etc., right? So again, sequence number 0 means it is your starting point. So starting point typically refers to a single coordinate that represents the initial location or a reference point, right? So we won't be creating any multi-point just yet because there isn't any single starting point for the entire multi-point, right? So what I'm going to do is, first, I'm just going to create a starting point. So in order to do that, I'm just going to create a CTE, right? Starting point, right? I'm just going to call this. Let's call it starting point, right? Something like this. Starting point. So again, the starting point refers to the location, right? The first initial location. And this first initial location will have the first coordinates, right? So if you're going to say something like that, with starting point as, so here I'm just going to write, let's say, because it's around CTE, select. So it's going to be similar to what I've written here, right? So it's going to be similar as written here. So I'm going to do, it's going to pick something like that, right? Something like this. It's going to copy paste under here. And then I'm going to do where sequence number is 0, right? Something like this. So I'm just gonna do, let me see if my CT is actually working. So I'm gonna do select from starting point, right? Make sure if you create your ever first CTE, test as long as you go, right? Okay, first we create a starting point. Secondly, we create, let's say, what we're gonna do here is, because we're wrapping this around with CTEs, first we create the starting point, and then we create the others. So one select statement with our starting point, the next select statement with all the points, right, which has sequence number not equal to 0, and then the next select statement will be joining those tables together. So you're joining the origin or the starting point with all the, let's say, with all the points that doesn't have a sequence number 0, right? And then the last statement will be your lines and polygons, right? So, so looking into this, let me see if it's actually working. Okay, we've got something like this, right? So what I'm gonna do is, the way I do it is I use this for debugging, right? I'm just gonna comment this one out, right? Comma, right? The next section we're going to do is we're going to create a multi-point, right? Multiple location. So if when I say a multi-point, for example, it means the starting point can have a line going to 2 or more directions. So we need to get the coordinates for them, right? So in order to do that is, okay, if I just put a comma here, and the next statement would be something like, okay, I'm going to say, let's say collect all points, right? Something like this. So I'm going to do select. So in order to do that is, I'm just going to copy, I'm just going to type it in, right? nation or region name. Say type. Do I need the sequence? Sure. Okay, let's keep. Don't really need the sequence number, so it's going to be part. I'm going to do something like this. St collect, right? And then I'm going to say, it's going to say geo points, right? Geo points. So from this particular table points in order, st collect. So let me show you what st collect means. So in order to let me quickly see something. Why did I do something? No, this shouldn't be like this. I think it works the same way in it. So I'm gonna change this to geo points from points in order. This is how it works, right? Something like this. Okay, for time point. Let me see if it's actually working. Right. So you execute one select statement at a time, right? And then this. So st collect. So going back to Snowflake documentation, there are two forms of st_collect. It's a scalar which combines two geography objects into one, and it is also denoted as an aggregate, right? Which is this function combines all the geography objects in a column into one geography object. So if you scroll down here, so if you see here, looking into, let's say, this particular usage nodes. So if G1 and G2 are both points object, the result is a multi-point object containing the 2 points. Similarly, if G1 and G2 are both line string object, the result is a multi-line string object, etc. So here you can see if G1 and G2 are different types of geospatial object, or if at least one of the input geography object is a collection, for example this, then the result is a geometry collection containing both input objects. So of course, we're not going to look into that more precisely. It's more of the first point. So we need to create a multi-point object. Again, what I said is the reason why we create them is because your starting point can have a line going to multiple directions, right? So you have a multi-point connected from the starting point, right? So this is why we use st_collect, so which is an aggregate function to create a multi-point value that contains all the points in the same column, right? So what we're gonna do is let's see, this is create that. Going back to Snowflake. So you use st_collect. So geopoints is basically your coordinates, right? So I'm gonna do here is say where sequence number that's not equal to 0, right? So because this is an aggregate, right? What I'm gonna do is I'm going to group this by part and nation's region name, right? Something like this. Yeah. So I'm gonna do select from collect all points. Run this. So now you can see we have a multi-point. This is a multi-point, right? Just for this particular region, right? Scotland. Of course, it will contain a lot, right? Because it's a nation. Obviously, if it's defined as a nation, it will contain n number of points, right? So if it's a region, right, with the southwest, it has little, right? So this is an example. So of course here Scotland's nation. We have another Scotland here as a part, right? So this has tons of let's say coordinates, right? Which you can see here as well, in order to make up the whole nation of Scotland, right? So this tells me, okay, we have a multi-point object, right? Now, so what we do with this is we're going to create, let's say something like um let's see something in here. So what I can see is looking into this. Okay, let's pick up this one here, right? Because it has n number of coordinates. So it has part 45. So going back to this table here, let me just what I'm gonna do is just copy and paste underneath. So I'm gonna say where goes 45 and nation or region name. Scotland, right? Okay, you see, of course, it has a number of coordinates, right? You can see here, it contains 184 brackets, right, with the word Scotland in them. So this is one way you can check, okay, this is basically grouped, right? So of course, because we use st_collect, which is the arg function, this is grouping by this coordinate, right? So, this is grouping by this nation, right? And this is what we get, right? So going back to, let me pick up another example, right? So let's see what else we got in here. Something, okay, this bit, okay, let's pick up something like this. So this is, okay. So running this table, right? So I'm gonna do here is, I'm just gonna choose another example. So I'm gonna do, scrolling down the list, okay, pick this example, 5 nation, right? Should I get the nation here? Okay, 5, that's fine. Let's just try with the nation. Just gonna say Scotland. So I'm gonna run this. So if you see here, what you get as, okay, let's choose 5, right? 1, 2, 3. So therefore, running this command here, you will get 1, 2, 3, and 4, which is sequence number 0 because we have excluded that, right? So we'll have 4 coordinates, right? 1 is the starting position, and the rest, let's say the rest 3 of them are your not your starting position, but just the coordinates that draws the line between the starting point with those multi-points, right? So running this, you get total of 4, right? So let's see. Okay, this is all done. So I'm going to just delete this bit here. Just going to comment this one out. So we have collected all the points, right? So next step, what we're going to do is we're going to join them. We're going to join this table here, which is the starting point, with this table here, right? So what I'm going to do is say join. I'm just going to call it join points, right? You can just choose a different name, but I'm going to choose this name. So I'm going to do here select. So I'm going to do CP nation, so call it CP nation region name. Secondly, I'm going to say CP type. So it's going to copy this table here. P part. st_collect. So for st_collect, I'm going to call this as, I'm just going to call this as an alias. Let's just call this as collected points. Okay, let's call this as cp.collected points, right? And then I need the starting point, right? Which is 0 points. So it's going to call this, because this comes from a different table, so of course you need a different locations or different table, which means you need a different alias, right? Which is starting point. So I'm going to call it sp 0 points, 0 points, right? I'm just going to create something like this, but I'm saying 0 points as your starting point. You don't necessarily need it, but just keep it as it is, right? 0 points. So 0 points here. What I'm going to do is, I'm just going to do right down here as your starting point, right? Just going to delete this part here, so it's much more easier, right? Point, right? Starting points, right? So many. Okay, we've got this table now. I'm just going to join those tables together. So I'm going to do from, call this as collect all points, CP. What I'm going to do, of course, in the join. So I'm going to join that with starting point, right? Which is called, what's it called? Starting point, right? This table starting point SP on, it's going to say on SB nation or region name, CP SP nation or region name, and CP. It's gonna copy like this, right? CP type. So it's gonna create starting point as type sequence number part, right? So if you need the sequence number, we're just gonna say type and part, right? Speed type and CP what's it called? Part, right? Yeah, part equals sp.part, right? Something like this. So we're going to join those two tables, right? So let's see if you receive answers that we wanted. So we'll do select from join points. Okay, now we've got a table with the starting point, right? And with this. You can notice something else. You see here, this point is not really wide off, right, from the collector points. Look at this. It starts with -7, something, and this starts similar, right? So we know this is going to be a starting point because they're very close. Imagine having a starting point as something like -1 or something else way different compared to my collector points. So that's an indication that something is wrong, right? And you won't be able to create those coordinates properly because if you create a line, it's not going to connect well, right? So pretty much I'm happy the way this works out, right? Now we got all the points. It's going to comment this one out. So the next step is we're going to create the line between the coordinates. So in Snowflake, we have something called st_makeLine. Similar to make point, we have make line. So in here it says that so it constructs a line connecting the points in the input objects, right? So it presents a line connecting points in the input object. So for example, if you see here, let's see some examples here. st_makeLine. So we have a point, right? So you cannot use make line when you have a numeric value. It should be a type of geography, right? So if you see here, let me show you something. Going back to Snowflake, let me just run this table. All right, this bit here. Yeah, I'm just going to show you something quickly. This is not a varchar or number, right? So here, if you say describe table, point in order, something like this, you can see here the last column is a type of geography, right? In order to use make line, you need a coordinate, you need a point, and then within the point, that's where you create your line, right? So let's just try this one out. So I'm just going back to the CTE. It's gonna say call it something like make 9, right? Something like that. So I'm just gonna create select statement. So what I'm gonna do is let's see how we're going to create the line here. So first thing what I'm gonna do is I'm going to of course, in order to make a line, imagine this, right? If you see this one, this bit here, you need all the necessary columns, right? So if you see, for example, this join points, right? Look at this table here. You need all the columns, right? The reason why is how would you make a line without having the starting point? So if you just mess this one up, the only way to make a line is you start with the starting point and connect that starting point with n number of coordinates, which is the multipoint, right? So if you receive something else, and if you do not create a starting point, then you won't be able to draw a line, right? So let me show you how it works. So if we're going to do something like this, right? Nation, region name, right? Just similar to the one above. Type, part, something like this. And then I'm going to do, so I'm going to do st, I'm just going to make line, right? Something like this. So here, your line, I'm going to start with the starting point, which is your initial location or initial like reference, right? And then I'm going to do comma, collector points, right? Something like this. So this is your line. So I'm just call this as line. from, let me quickly comment this one out. So so here, what we're going to do is from join points, right? So something like this. Okay, let me see how this everything looks like. So I'm going to do select make line. Okay, now you can see if you create a line, if you see above to the Snowflake object, you see here back to Snowflake documentation under make line, you can see that it created something called line string, right? So this is a line between this x-axis and this y-axis, right? So here you can see, for example, if you're looking back to Snowflake, okay, this is creating a line for all the coordinates specified here, right? Your x and y-axis, etc., right? So this is where it draws a line, right? Because we're creating a polygon here. You cannot create a polygon unless you have a pointer and a line, right? Like a coordinates and lines, right? So looking into this, okay, we got the line, right? So how do we actually create a polygon? Right, that's the next question, right? So for example, remember what I said earlier on. In order to construct the line connecting the points in the input object, you need to create a polygon, right? So this function where it says line string is the outer loop, right? It must form a loop, right? Because the last point in the sequence of points defining the line string must be the same point as the first point in the sequence. Yeah, just remember that, right? Because a polygon itself does not have any holes in them. It's just a picture, right? And it's just created as loops, right? You need to have n number of, let's say, numerical values with a line string in order to make up the polygon. So how do we create a polygon is in here. Instead of me creating another select statement, I can just create the same one here. I'm just going to say make poly. And here, I'm just going to say make poly, right? So here, instead of saying st_make_line, right, keep this st_make_line here because you need a line in order to create the polygon. You have something called st_make_polygon, right? So here it says the function uses the specified line string as the outer loop, right? As I mentioned before. Here it says, I mean, you don't really need this, but this is not really for us. But I think if you scroll down underneath, it says here the lines of the polygon must form a loop. In other words, the last point in the sequence of points defining the line string must be the same point as the first point in the sequence, right? So here, for example, this shows the simple use of the st_make_polygon function. The sequence of points below defines a rectangular area, right? So this is quite difficult to understand what type of shape it is, right? Because you have numeric values, you need to use some, your intuition just to understand what this particular shape will be, right? But what I'm going to show you is, I'm going to show you how to actually visualize your polygon on a map, right? Before doing that, let's just create the polygon, right? In order to do that, bear in mind one more thing is, you see here, it's given as line string, right? You cannot create a polygon, right? Let's just go back to this one, right? Not the geometry, the geography example. So you use this line string, right? In order to make up this polygon, right? Because if you create a polygon on top of, let's say, coordinates, it won't work. On top of any other data types, right? It should only work on geospatial geography type of data type, right? And it should be lines, right? Because within the lines you have points, within the polygon you have different lines, right? So you start with the points first. After the points you create a line, and after the line you create a polygon, or else you will receive an error. So I'm going to do is going back to Snowflake. I'm just going to say polygon, right? Something like this. Poly. Let me see if I spelled it correctly. st_make_polygon, right? Just go make polygon, right? So here, if you see here, They say T. Okay, let me see something like this. Okay, construct a geography object that represents object without holds, right? Okay, this is similar to the Snowflake documentation. Okay, let me just create something like this from join points, right? I'm just gonna create and run this. So you can see this is a polygon, right? Now, what I'm gonna do is after creating this polygon, you need to use something else, right? Because this is not done yet. Okay, you have the polygon. This is basically changing the name to make line to polygon, right? This is what it is. But remember what we shown earlier. We want to use this command here. We want to group this by everything here, right? We want to group this by, let's say, the nation, the type, and the part, right? So how do we do this is because what I want to achieve is I want to have one polygon, right, with one nation or region name, right? We want to group this by that particular nation or region name. Because this is difficult for me to find out, okay, what are the coordinates? Because this tells me the same as this, right? Because you see here. But of course, no, the coordinates are different, but if you see, no, sorry, I mean the coordinates are different, but if you see the part is this also different, but these two are the same. So I'm gonna do is I'm gonna group this not just by having like having clause or whatever. In geospatial data, the only way to create aggregates is to use st underscore collect statement, right? So I'm going to show you how it works. So here, what I'm going to do is select. Just going to call this nation or region name, right? And then what I'm going to do is part. And then here I'm going to say st collect. Let's say this is going to be, let's say poly, right? Let's call this as poly, something like this, right? So I'm gonna do group by nation or region name. Okay, again, what we're trying to achieve here is I want to create a single polygon with all the coordinates that has type Scotland and other one type, let's say, southwest, etc. Right? So I'm just gonna run this because this is aggregation. It's just basically me aggregating things, right? Now we have received let's say 165 records, right? Now in here, what we're gonna do is move the part. I don't think. Start. Okay, I'm gonna do here. So looking into this, we have the national region name. We have all the regions, right? No duplicates. We have the type, and we have the whole polygon. Remember what I said. I want to, instead of having different parts in duplicated names of nation region names, right? What I want to do is I want to see one record that tells me the nation or region name with the type, whether it's nation or region, and with the multi-polygon with all the necessary coordinates and lines, right? So how do I check whether this particular multi-polygon object is actually Wales? So I'm going to show you quickly. So what I'm going to do is copy this bit here, right? And I'm going to show you something using this, right? This is called OpenStreetMap WKT Playground. So well-known text file playground, right? So what I'm going to do is just copy and paste this. Just scroll up all the way to the top. If you want to use this website, there's a link in the description, and you guys can play around with the multi-polygon. So here, with the multi-polygon object, I will, copy paste into this box here, and I will plot shape, right? Now you can clearly see this area is Wales, right? This is Wales, right? So if you see going back to this, it's telling me, okay, Wales nation. So let's just choose something else. I'm going to choose London, right? Just going to copy this And going back to this, I'm just gonna delete, paste this, plot shape. You can clearly see this is London, right? So these coordinates are actually real, right? So this is how it's been designed. So if you see here, all the edges, right? You have given different points, right? And you create a line, right? This is why we use st point to create those points. We use st make line to create those lines, and polygon to have this particular shape with those holes in it, right? So let's just choose another example. Let's choose Scotland, right? It's gonna do Scotland. So what I'm gonna do here is it's gonna copy and going down here. Here, look, this is Scotland, right? Okay, this is how it works. So I clearly can tell that from what I've got from the result is correct, right? Okay, so that's how you do, work with geospatial data. So next one I'm going to do is similar to what I've done here. I'm to create for the Westminster table, right? So I'm just going to create, say, Westminster table here. So I'm going to do similar to what we got, right? Just gonna copy and paste this CTE quickly from here. Okay, something like this. What I'm gonna do here is let me see the table. So I'm just gonna paste underneath. Just make sure that you have this for reference. Okay. It does not have this, so choose twins. It doesn't have a type, so it has sequence number. Let's see. Okay, wait, hold up. Where is this table? Points in order. So I need this table, right? What I'm gonna do is just create the table on top of that. I'm gonna do constituency. Right, it doesn't have the type. Something like this. From this table here, just gonna do something like this, right? It's gonna run this. Oh, my bad. I'm just gonna do it like this. Okay, that's successful. Let me see. Points in order. Okay, I've got this. So going back to this here. Starting point, okay. It's going to just remove the ones that have nations or regions and delete type, right? Delete this part here. So I'm gonna do is check this. Okay, it's not working because of this. I'll run this again. Make sure the second select statement is working fine. Yes, we got the multi-point. It's going to comment this one out, join points. So we don't have the type. We don't have the region name. It's called something like this. This is in capitals, but that's okay, that's fine. Let's see. Type, we don't have a type. Okay, we just only have those two. Let me see, select join points. I've got any errors? Nope. So we have the starting point, we have all the rest of the coordinates. And then what I'm going to do is, let me comment this one out, right? I'm just going to create my polygon here, right? So we don't need type like this. So I'm going here, I'm just going to say select. Let me see what we got here. Yeah, we are similar to this, right? Type. Okay, it's called poly. Okay, this is going to be called okay. We got something like this now. Not familiar with some of the cities here, but let's just test out for one. Let's choose, let's say, what's the best candidate? Nottingham East, right? What I'm going to do is copy this, going back to this here. I'm going to copy this bit here, plot shape. Yeah, here, look, Nottingham, right? So this is going to be Nottingham East. So it looks good. Let's try Winchester. No. Let's see. Well, and some Pancras, right? This is of course in London somewhere. So I'm gonna do just test this one out. Plot shape here. Okay, some Pancras, right? And let's choose one more. Let's make sure this is all good. Let's see. What could be a good candidate here? Say, let's say Petersborough, right? So copy this bit here. Paste this multi-polygon plot shape. Peterborough, right? Here we go. Okay. Is this bit? Okay, that's fine. City of Peterborough. Okay, cool. I mean, that makes sense, right? Okay, going back to Snowflake. So we got those two, right? What I would do is just, it's pretty much better if I create this table, right? Create replace table. So I'm just going to call this Westminster. Let's call this Westminster table as this select statement, right? Something like this. And then what I'm going to do is just run this. Okay, I'll just call this. What shall I call this as? Let me call this as poly, something like this, right? Okay, I'll just call this poly. Okay, I'll create this table, right? Okay. Yeah, I'm not sure why free I need to. Okay, let me choose. Okay, because I forgot to create a table on top of the nations regions. Let me just do that quickly. Nations and region. Let me see. Nation or region. Nation or region. Name. And this has type. And this one, same thing. Okay. Identify. Let's see. Nation or region name. See quickly. Order by. Oh, sorry. Order by. Sorry, from this table here, right? So it's gonna be something like this. Okay. Let me see. Cool. Let me just create this table here, so we won't lose any self information. Here. Create or replace table. Let's just call this nation or region polygon, right? Something like this. As statement like this, right? The whole thing. Machine kind specification. So this should be as poly. Running this. Okay, we've got two tables now. So you got the first one. So nation and region polygon, right? Okay, now we got two tables. So one's called Westminster table and the other one's called nation and region polygon. So they're both multi-polygon, so that's fine. Looks good so far. So the next step, what we need to do is if you look into the question, back to this challenge, we want to create the intersection, right? So it says here, and then work out how many Westminster seats intersect with region polygons, right? The only way we need to do this is in, let's say, um, how would you say is if you look into those two tables, that's an indication that you have to first join those two tables, right? Use a join command. And we need to talk about another function, which is called st-intersect, right? This bit here. So open up your Snowflake documentation. You can see that st-intersect on Snowflake documentation, we see here returns true if the two geography objects or the two geometry objects intersect. So share any portion of space, right? So when I say it returns true, so we know this is a Boolean, right? So it's not a number, it's not a geographical object. It's basically a Boolean. If two points intersect, or two polygons actually, right? That means it will return true. If not, it will return false, right? So that's what we're going to try build. So what we could also do is because it's a type Boolean, why not define this type Boolean in the join condition, right? Because if you create a table and those join condition, let's say inner join, let's say select star from A, left join A on, and then you have a.id equals b.id because that's basically a Boolean, right? Where those two match. So we can introduce st-intersect command into that join condition, right? So the way what I mean is, okay, let's just create a view on top of, let's say a view. We're going to create a view as our result output, right? Let's say create view results, right? As let's say select. Let's call this np nation or region name, right? This is what we called here, right? Nation or region. Well, we have called nation region. Let me just do this as an alias. Nation. Just gonna make sure this is similar to what we got here, right? Nation or region. We're gonna do count, right? Because the reason why we go count is because it tells us to work out how many of them, right? So we need to get the count of. Let me open up the Westminster table, right? Of this, right? This table here. So count of. Let's introduce a new, say WT. Let's see. Similar to that. So what do they have intersecting? So I'm going to do something like this. From. So what I do here is going to do something like that. So from the first table, so our first table is called nation region polygon, right? Which contains the nation itself, the region. These contains only little parts of the area. So I'm going to do left join, right? Because we want to get all of them. Left join only, let's say, let me give this alias, np, left join this table here, Westminster table, right? Call this wt, right? On st intersect, right? So you have intersection, which is geography. Object returns geography that represent the set of points that are common to both input object. And this is of course similar, right? You see here. Just to prove a feature open returns true if the two geography object or the two geometry object intersect, right? st intersects, right? Then here what I'm going to do is, again, we're going to do say np poly wt poly, right? Just see if they're both intersect, if it's true, right? Similar to that, and I'm going to let's say let me just run this. Okay, you see here what's the count? I'm just going to group this by the first one here. I'm just going to say 6, right? And what I'm going to do here is, instead of saying group by this, etc. So some people that do this, and they don't know what to group by. Are they using this name or are they using this name, right? Of course, it's easier to say like you're using the first column, so you say group by one, right? So I just wanna do something like this. If I run that, okay, we have something like this, right? And then what I'm going to do is just go back to the question. Did they order anything? I think this is telling me this is a descending order, right? Let me see if I do in descending order. So here, I'm just gonna say order by. So here, instead of saying or writing this whole column here or this bit here, just say second column descending order, right? So it's gonna check whether this is correct. Okay, I've got something like this. I've got 11 records. So let me see, 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 11. So I've got 160, 95, 91. So going back to this, 116, 95, 91, 82, 80, 78, 82, 80, 78, 76, 70, 63, 70, 67, 70, 63, 50, yeah, 53. Okay, got exactly the same. 30, 53, 63, 70, 60, 78, 80, 82, 91, 95, 160. Okay, let me just create a view on top of that. Just gonna create something like this. Oh, sorry. Create. Oh, it all exists, right? I think I accidentally. Let me see. From result. Okay, hold up. Let me just quickly fix something. Place view. Okay, now. If I want to see this table. Okay, I got exactly the same as the output given here, right? So yeah, this is how we handle with geospatial data. So give this a go and see if you can play around with the data and the OpenStreetMap-Playground page in order to see the result that you're hoping to get. So this is one of the reasons why this is something difficult to work on. Geospatial is always pretty much a little bit intimidating to work on to begin with, but hopefully today this gives you some basic idea on how to build polygons and how do we actually see those results on a map, right? So yeah, hope you understand this session on geospatial data. So thank you for watching and I'll see you on the next video.